Guys, welcome you all. So our today's topic is Prim's algorithm. I'll first give you some description in PPTs and tell you some little things about it, and from there we will move to numericals.
So let's start with the PPT. So our topic is Prim's algorithm. Now, in Prim's algorithm, let our first question arrive is what is Prim's algorithm and why is it used? So basically, it is used to find the minimum spanning tree. What is the minimum spanning tree now? So in the spanning tree, when we cover all the vertices and find the minimum weightage path, it is known as minimum spanning tree. And I'll show you further with the help of numerical. So MST is used at different places in real life. For example, Google Maps. Let's take you want to go to three places A, B, and C, or six places A, B, C, D, E, F. So what is the minimum path? What which will have the minimum weightage you should use by covering all the vertices? Which one you should cover first? So this is what is done by Prim's algorithm. You can see it in Swiggy and Zomato, like if you have its group delivery. So first the delivery man should serve which path, which point. It will be solved using MST, and you can use Prim's algorithm too. So now the question arrives is how does it work? So first of all, you have to choose any vertex. Then make the sets of paths from the vertex. What you have to do, like from vertex A there are two paths going 2 and 3, so you have to make the set of a path. Like you can make set A, which will have consist of weightage as 2 as well as 3. So then you have to choose the minimum weightage among them, and similarly you will be making more and more sets by reaching different vertexes. Now the crucial point comes. You have to choose the minimum weightage among all the sets available. Okay, and at last the answer will be which shortest paths you have chosen. The sum of all that will be your minimum spanning tree. So here in A, B and AF, let us choose vertex A. So there are two paths from vertex A. It's AB as 4, AF as 8. So which one should we choose? We should choose AB because it is the smallest weightage, or the minimum weightage part here, AB. So let's take it as 0 source, and then we have chosen AB path because it is the smallest here. And then similarly, when you reach B, there will be paths like D 9, BF will be 9, BD will be 8, BC will be 10. But since my 8 of AF is also remaining, so I will choose that path AF and I will travel that path.
So now let us see for the algorithm. So now the first step here is for each U belongs to the VG. Now here V is the vertex whereas G is the graph. So for every U which belongs to the vertex of graph. Now the second is do key U infinity. So we will mark its weightage as infinity. Like in this figure, we have marked B as infinity. Here let me show you. Here we have done it as infinity, and I will do every key U as infinity. Here this, here in this, here in this we have done infinity. And now the next step is the parent of this U will be nil. So let us consider, since it is not as directed graph, you can consider every parent as nil. But now since I'm taking A as source, so I'm doing this for nil, and I will do this with nil. So for here the four steps are complete. Now the key of the R, key here, R is root, the key root will be 0. So since it is the key root, we will consider it as 0. Now what is Q? Q here is the array of the vertex of the graph. Now Q is A, B, C, D, E, F. All the vertexes are covered here, and it is the Q. Now the Q, this whole loop will still here, this will run until and unless the q will be 5. Since the q is not 5, this will run, and once the q will be 5, the q will be nil, it won't run. So what you have to do is you have to extract the minimum of the q. So what will be the minimum of q when I'm traveling from a to b and a to f? It will be 4, so it will be selecting 4 for each vertex which is adjacent to the u. Since I'm taking this as the vertex, which are the adjacent u's? It's AB as 4 and AF as 8. These are the adjacent vertexes, right? So here for each of these we will compare. Do if v, which the vertex belongs to the array q, and the weightage of u and v is less than the kiwi. Here what is the kiwi? It is infinity. Here since 8 is less than infinity, what we will do, we will change the vertex, the parent vertex with the u, and we will mark here it as 8, right? Now the kiwi will be interchanged. So this is the algorithm, guys. I hope you understood it. So thank you everybody. From here on we will be moving to numericals.
Here, our first problem for Prim's algorithm is this. So, as I told you in the PPT, that first we have to choose a vertex. Any vertex we have to choose. You can choose any of these vertex. So, let us say that I'm choosing vertex A here. So, from vertex A, what are the distances from vertex A? So, from vertex A to C, we have what? Let's write A here. Then from vertex A to C we have 4. The weightage is 4, right? And then from A to B the weightage is 4 similarly. So now we have to choose the shortest path, but since both are equal, so we can choose any of them. So let us choose this AB for 4. So I have, you can cross it because you have choose this path. You have chosen this path, so I have chosen this path AB as 4. Now I have reached at vertex B. Now from vertex B, what all I have 2 to reach C. Only this is the 2. So now I have to see the minimum in both of them. So what is the minimum between 2 and 4? So it's 2. So let us take the path 2. So what is 2? Having what point is having weightage as 2? So it is BC, right? So I have traveled BC path. Now I have reached at vertex C. So there are paths 3 and 2 and 4. Now in these three, what is the minimum? So as you can see, 2 is the minimum here. So I am choosing this path 2, and now I will travel the path CE with the minimum weightage here. So I will cancel this, right? So I have traveled till vertex E. So I will write here vertex E. Now I will see what are the paths for vertex E. I have only 3 here. Now let us see what is the minimum between all these. So 4, 3, 4, 3. So 3 is the minimum. Which 3 should I choose? So it's totally dependent on me. But yeah, when you are choosing something as the lowest, so you should remember that it should not make any cycle. It should not have any cycle. So if I choose this 4, if let's say I have cancelled all the 3's and I have only 4 as remaining, so I can't choose this path because this will be a cycle. So I will choose this 3 EF, right here. So EF is chosen. So let us cross this. Now where I have reached at vertex F. Now at vertex F I have 2 paths 3 and 4. You can see here 3 and here it is 4. Okay, so now the minimum is 3 again. So what can I choose? I can choose this 3 as well as this 3. So I will choose this 3 to reach at vertex D. So now I have reached at vertex D and I have cancelled it as well. Now this I have reached. So I have reached all the vertices, and so all the vertices, and my covered path will be the minimum path because I have selected all the minimum paths, right? So I have reached at vertex D. So since I have reached vertex D, I have covered all the vertices A, B, C, D, E, F. So I have covered all the vertices and this was my path traveled, right? And I have chosen all the minimums. So what is the minimum spanning tree? Let us see what is the minimum spanning tree, right? Spanning tree. So it is equal to, I will sum all of these. It is 4 plus 2 plus 2 plus 3 plus 3, which is equal to 4, 2, 6, 2, 8, 8, 3, 11, 3, 14. So our answer is 14. So our minimum spanning tree is 14. We can't have any other path which is minimum than that. So the best minimum spanning tree is 14. So this was the numerical. I hope you understood it very well. If you have any doubt, please tell me in the comment section.